Hey everyone, and welcome to the Private Podcast, where we plug in and explore the intersection of privacy, human rights, technology, and democracy. I'm your host, Derek E. Silva. Today we are speaking with Paul Syverson. Paul is a mathematician at the US Naval Research Laboratory Center for High Assurance Computer Systems. His research interests include computer and communication security and privacy, with an emphasis on theory, design, and analysis of traffic secure systems. We will dig into that, especially onion routing. Paul, thanks for taking the time to be here today. We really appreciate it.
Glad to be here.
Good stuff. Let's dive right into your background and the sorts of things you're up to right now. Can you tell us a little bit about your background and what inspired you to become a mathematician?
Uh, well, my training is as a logician. Most of my graduate degrees are actually in philosophy, but I also
Hmm.
have a master's degree in mathematics. My PhD is in logic, and I have a master's in philosophy. Um, so I don't know. I've always been interested in reasoning about things and learning how what ought to follow from what, and yeah. So that was my interest in mathematics and understanding how the world works. Um, that's yeah.
Perfect. No, I think that's great to have that sort of interest and that drive to pursue it more or less as a career. Really pursue that interest and dive into those questions. How does that segue into your research at the U.S. Naval Research Laboratory? What are you up to there?
Well, uh, I answered an ad in Jobs for Philosophers, which back in the late '80s was a paper. Now it's a website, and my then section head was very smart, and he understood um, uh, that the salaries you could offer to people with backgrounds in philosophy might seem competitive versus people with degrees in computer science. It's hard to get good people, but because he also had a background in both philosophy and computer science, he knew that there were good technical people operating there. And so I was working on a PhD at the time in epistemic logic, logics for knowledge. And I started, the first thing I was working on was logics for authentication, for reasoning about authentication protocols. So
Hmm.
if, for example, uh, Alice sees a message that's encrypted with a K that she knows is good for talking to Bob, then she should believe that at some point in the past that Bob said the content of that message. Now that by itself isn't enough. You need other rules because, for example, suppose Alice and Bob are in ATM at a bank. You could have an encrypted message between them that says, uh, dispense $100 from Derek's account. And that's fine, that's great. But what if you just save that message and replay it the next day?
Hmm.
Then you could
Hmm.
just be emptying Derek's account with perfectly secure encrypted messages. So you also need to have other rules that make sure that Derek is there now and is talking and that it's current. And so I was working on ways of analyzing that sort of thing, and it was a natural extension of the work I was doing.
That's terrific. So two things I learned there. A, people still use Alice and Bob, which is great. I'm a former network and sysadmin, so like everything was about Alice and Bob, especially in programming class, which I also took. And uh, I think it's fantastic that there was a paper called Jobs for Philosophers, and I'm glad to hear it's hopefully still around as a website. That's a
Yeah.
very '80s thing to happen.
Well, it was a publication from the American Philosophical Association. So
Nice.
most of
That's
the jobs
terrific.
were, 1 year replacements for people going on sabbatical from, various places. And in amongst all of
Yeah.
those was this ad for the US Naval Research Laboratory. And I remember sitting around the reading room with the other grad students and saying, "What?" And I'm like, "Well, check it out."
Why not? That's different.
And
Yeah.
I thought I would go there for a year and get my dissertation done and then go back to doing the interesting stuff. That was the late '80s. I'm still here. It's still interesting.
That's awesome. That's great to hear. Can you also tell us a little bit about onion routing and how you invented it?
Well, one of the short ways I like to say that is carpooling. Um, Mike Reed was the one who probably first posited just as a puzzle. He said, is can you somehow have a connection over the internet where Alice and Bob are able to communicate with each other, but the infrastructure doesn't know who's talking to whom just by moving the bits around. That seems contrary to the way network protocols work. And
Hmm.
so he was wondering about that, and he was sharing an office with this guy, David Goldschlag. David and I used to carpool together way back when, and we would talk about this back and forth, and then we'd get to work and get in front of a blackboard, and yes, it was a blackboard back then, chalkboard, and we'd sit down with Michael, and we'd sort of just work out what was possible, and then we also, of course, started to think about uh, what could you use this for. We're tasked to think at NRL with about not just things going on now, but things that might be useful, well into the future. So at the time, the web was just a few years old, um,
Hmm.
uh, and
So this is like mid to late 90s. Like if we're
mid
talking
mid
about World Wide
'90s.
Web, mid 90s.
Yeah,
Okay.
yeah. So mid '90s. I mean, the original protocols maybe started the work. I might get this wrong, but maybe even in the late '80s. But
Yeah.
Mosaic was NCSA Mosaic was with 92, something like
91,
that.
92. Yeah.
91, 92, something like that. Yes,
Yeah.
and so we started this work late '95, and um, actually, so. I remember, late night pundits talking about something they called the Pentagon Pizza Channel, which was when Operation Desert Storm Desert Shield was
Oh, okay.
transitioning to Desert Storm.
Yeah.
Somebody noticed that the number of orders of pizzas at the Pentagon went way up. And they said, so they didn't know what was up, but something was up. And then lots of people were commenting on this. And we said, okay, nobody's doing this now. But imagine if in the future you could order a pizza over the web. Who knows what you could use the web for? And you know, to take advantage of this channel, somebody had to be sitting out in front of the Pentagon. But if you could order over the web, then anybody just watching the network could see communication between the pizza places and the Pentagon. So if we had a
Yeah. Yeah.
way to make it and it's important here, so it's not just whether or not it's encrypted. You don't care whether people are getting, pepperoni or anchovies or something. What you care about is, oh, there's a huge amount of traffic between the Pentagon and the pizza place. So that's
Dominoes.
what, yes. So that's what we needed to protect, was things like that. Um,
Yeah.
that was yes, the origins, I guess.
So, well, I think we might have got a little bit sidetracked. So you were at a blackboard. What was going on what were you actually writing on the blackboard? Like what sorts of things were you diagramming out and writing down to
Well,
actually
we were
figure
just
this?
trying to think, how could you do this? And some
Oh,
of
okay.
the
Yeah.
some of the first things we had in mind were similar to something called a mix, which we didn't actually know anything about. And when we submitted our first paper, people said, "This is just mixes," and we said, "Oh, what is that?" That we didn't know. So David Chaum, a brilliant cryptographer who invented lots of things, he invented mixes a few years before us, and it took us a while to realize, no, it's not quite the same, because we were using layered encryption, which they both did.
Hmm.
Mixes also used it, but and we first thought, oh, take individual messages and wrap them up in public key cryptography and in layers, and then send it to the first place, and then have them strip off the layer and send it to the next place and move on like that. But that was too inefficient. It's too expensive to do public
Hmm.
key operations. So
Especially
we
then.
yes, it was all the worse, and it was and much weaker crypto, but still very expensive back then. And so we thought, well, how can you do this over a circuit and have an actual connection so that you can have bidirectional communication, like on the web?
Hmm. Hmm.
And um, so we hit on the idea of using the public key crypto just to build the circuit. And this is where the word onion came from, because a lot of people think it's the layering, but it's more than that. It was essentially just layers with nothing in the middle. So each layer, and this isn't how Tor does it nowadays. We've changed things a bit so that you can get some other properties like forward secrecy. Uh, but the original first way we had to build a circuit, you had a layer of public key crypto, and you would connect to the first onion router, and they had the private key, so they would strip it off, and that would be they would get a session key that was going to be used for actually moving the traffic around, and the identity of the next hop, and then they would send it on to the next hop and the next hop, and the last one they were done. There was nothing there, so they
Right.
they just sat there and waited, and then the first traffic that came through told the last onion router, "Oh, please connect to this internet destination," and then they would go out to where they needed to go. So, and
Yeah,
we
which
were
is
working these things out. I it was a lot of back and forth, people working together. I do think I was the one who suggested the name onion routing because of this idea of layers with nothing in the middle. But uh, if David or Michael think they came up with it, maybe so. Um,
I'll have to go back and listen to the previous private episode with David. Alex
no, no, not
Kahaya,
David
the
Chaum.
former host.
David Goldschlag.
Oh,
I think it
Goldschlag.
was.
Oh, sorry.
Yes, I'm sorry. No, 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 no.
No, that's okay.
David Chaum
Right,
definitely
David Chong was the head of invented
invented
mixes.
mixes.
Yes. Yeah.
Yes.
My apologies for the
No,
mix up
no,
there.
no problem.
But no, but that's a terrific story. How do you think that technology, just onion writing in general, has changed how people use the web or communications protocols in general?
Well, uh, boy, in a lot of ways, I like to say that um, in many ways, onion routing and Tor and onion services are, I mean, they're still growing a lot, and they are roughly today where web encryption, HTTPS, things like that, was 15 years ago or so. Back then, if you had an encrypted website, it wasn't unusual. People were like, what's with that? Do you have some kind of arcane specialized use or something that you have in mind here? And no, it was
Or what
just
are you
for,
trying to hide?
yeah, what are you trying to hide? But nowadays we understand that it's a fundamental enabler of e-commerce. Cyber Monday's a few weeks away here. That literally
Hmm.
would not exist without web encryption. So as I said, we try to think ahead a bit about things, and so we were thinking about other properties that um, it's not, as I said, just um, the bits themselves, but also the patterns in the traffic matter, and that might be important. And we were thinking about, of course, Navy applications and government applications. You can imagine if, say, you're a patent examiner and you're visiting some company's site to look at their technology. Well, that has much more significance to to that company than if it was just somebody else looking at it. So, uh, you might want to hide uh, not just the particular location that it's coming from, but that it's coming from the government at all.
Hmm.
And then in the other direction, you might have a road warrior, somebody who's on travel. Um, and when we go overseas, you get training that says, don't walk around with an American flag T-shirt on or something because bad people. I mean, depending where you're going, of course,
Yeah.
somebody might try to uh, do you harm. But then you go back to the hotel and maybe you need to log back into work. Well, if you have a typical VPN that might hide specifically where you're going to, but if it's a Navy VPN, then it's going to be known that you are connecting to the Navy and that this is a Navy communication. So you're probably a Navy person, and much worse than just somebody standing around and seeing you on the corner somewhere with this T-shirt on. Somebody who works at the hotel or contracts the internet services for half the hotels in town could just look and say, "Oh, Navy communication. Oh, and because I have access to hotel information, they're in room 420 and they're checking out on Friday. So in a
Yeah.
way, that's much worse. So that was the kinds of additional communication security issues that we thought were important.
Terrific. For just in case somebody in the listening to this or watching this is uninitiated, what is Tor? And you mentioned that earlier too, so I
Ah,
think it's
I'm sorry.
important to
Yes, of
explain.
course. Yeah. Yes. Things that I
I
know
know what it
well.
is, but not
Not
everybody listening is going to
right.
know. So,
If I know it, doesn't everybody in the world know it? No. Yeah.
if
So
only.
Tor actually. So the name comes from the onion routing. So that's where it came from. So I've already described onion routing a little bit, that it's a
Hmm.
way to sort of bounce your traffic around different locations around the internet, and then it uses layers of encryption to make it hard for any individual party, even if they're uh, carrying some of those bits, to know where it's starting and where it's going to. Um, and when um, Roger Dingledine started working with me on onion routing, already we'd had a couple of generations of versions of it ourselves, and there were a couple of other uh, um, instances out there that people had designed. And so he told people, "Oh, I'm working on onion routing," and they would say, "Which one?" I said, "No, no, no, the onion routing, the original onion routing from the Naval Research Laboratory." And his girlfriend, now his wife, said, "Oh, that's a great acronym, the onion routing, and it works nicely as a recursive acronym, Tor's onion routing." So,
Hmm.
but so Tor is an instance of onion routing. It's a particular version of the design that we came up with, and we called that Tor. I mean, that design itself has evolved in various ways, but um, that's where the name came from. And then uh, I I'm tasked to do research, and as it came to be more used in general deployment by lots of different people, uh, um, the other folks started to get funding from elsewhere, not from research entities, which is where I get my money. Uh,
Hmm.
and so in 2006, they became a U.S. nonprofit, a 501(c)(3), if you know what that is. But they
I
became
do.
a nonprofit organization, and as a separate entity, Tor Project Incorporated.
Terrific. Thank you for that explanation. Changing the conversation a little bit here, what are some of your concerns around communication security and privacy? And obviously you came up with this protocol. It's benefited millions of people for a variety of scenarios. Um, I imagine there's still concerns around, I guess, just communications in general. There are still unencrypted websites out there. Encryption also helps criminals.
Well,
Where's your stance on that right
yeah.
now?
So, I mean, unencrypted websites. Fortunately, that has become less and less true. There's
Sure.
actually something that the Tor project did together with the EFF called HTTPS Everywhere, which is a way for if websites, if they had worked out that there was an encrypted version of website, that would automatically uh, put in that. To
Hmm.
some extent, it's gotten to the point where it's almost not necessary. And there's a mode in Firefox called HTTPS only, where if you set that, it will automatically try the encrypted version first, and then if that's not available, you get a warning that says, "Are you sure you want to go here?" But encryption by itself, of course, isn't enough, and I think you were alluding to this. Um,
Yeah.
uh, uh, TLS, the encryption that's used, the little lock icon you see, that's transport layer security, TLS. Um, uh, Hijack of TLS connections by means of hijacking the certificate, so you think you're going to a site, but you're actually going somewhere else. That is a big problem, and it's still a rampant problem. And it's a problem that, in many ways, I've been working on for the last several years. Um, you can't hijack uh, what's called an onion site because it builds the public key right into the address. So the only
Mm.
party who could possibly authenticate is somebody who has the private key. So just having a certificate from some authority that says, oh, there's a good key for talking to that site, it won't matter, because if the site doesn't have the public key in the address, then they won't, I mean, the private key, they won't be able to authenticate it. But onion addressers are these long looking, random looking strings. So
Right.
that sort of helps, but somebody could just give you a different string, and how would you know? So I've been
Yeah.
working on uh, what I call self-authenticating traditional addresses. So it's like a traditional address, but it glues onion addresses to them in an
Mm.
appropriate way. So the onion address is pointing at the TLS certificate, and the regular address and the TLS certificate includes the SATA. That's what I self-authenticating traditional address together, and that makes this sort of hijack much more difficult. And in fact, I'm presenting a paper next Monday at the ACM workshop on privacy in the electronic society on ways that you could potentially attack a connection to an onion service. There's something that Tor browser has in its configuration called onion location. So if a website has an onion address, you can just click on this button and it will redirect you to that onion address. And
Mm.
that seems like, oh, that's great, but it's first of all no more secure than the initial connection to uh, to that website. So it uses the same protections of what I call the less secure web, merely TLS and things like that. Um, but it's actually worse than that. And onion location essentially facilitates easier attacks where you don't even have to do a TLS hijack. And using these SATAs I described, you get stronger authentication. That's something that I think people often miss with onion routing and Tor. That it's not just about hiding things; it's also about providing better assurance. You know, when you make a connection out to a website somewhere, you have no idea where your bits are going on the way there.
Yeah.
And even if you do what's called a trace route, there's no guarantee that when you actually do the connection, it will follow that route. Um, but with onion routing and Tor, not only do you get the hops that it goes through identified, they're authenticated. They're cryptographically, you're guaranteed to have gone through those hops. So you get much more assurance when you make a connection of who you're talking to. And then
Right.
similarly for the destination if you use an onion service.
Yeah. I feel like I remember when Let's Encrypt came along and made SSL certificates free, and it was built into the cPanel web host server software. So like all these web hosting companies that made you have to go to Komodo or somebody else, VeriSign, buy a $20 or $50 or $1,500 SSL certificate and install it yourself. Like that whole process became much easier. You could literally turn it on by default. And I was running a web hosting service at the time, so I turned it on by default because I thought this was terrific. And
Well, that's
the flip
another
side is,
advantage. Oh, go ahead.
yeah, the flip side is that any website now can be encrypted because it's literally free. And so you ended up with the new scam was to clone a website, basically change one character in the domain so that an M looked like an N or something like that.
Right.
And
Doppelgangers.
it's like I'm on an encrypted website. So yeah, encryption is definitely not the end all and be all. It's a fantastic thing to have, and encrypts the traffic between you and the server, so to help prevent man in the middle attacks and that sort of thing. But you still need to go beyond that to actually make sure you're actually on the website you want to be on, and sending your
Right.
information to the intended destination. So yeah,
Yeah, and ghost
that's what
domains
I
is
started
an
thinking of right away.
yeah, and ghost domains is another problem. Um, there's been some analysis where, banking sites basically abandoned either an entire domain or a subdomain, and then people get the TLS certificate for that. We have, as an example, in this paper I just alluded to, um, there was an actual thing where there was a German promotion from Heinz ketchup, and they had
Hmm.
this promotion that said "Sags mit Heinz." Dot, I guess, .de or something, which is German for say it with Heinz. But they while the bottles were still in circulation and there was a QR code in the bottles that would connect you to this URL, they abandoned the domain name, and it was picked up by, I think, a pornography company or something. And so people were a little surprised when they got their ketchup bottle. So one of the nice things about SATAs is that even if the domain were abandoned, if you have a web browser that understands about SATAs, you wouldn't be able to authenticate to the onion part of that. And another advantage of these is that you alluded to Let's Encrypt. So as of about a year ago, you can get a domain validation, which is the typically the cheap for Let's Encrypt free version of certificate for onion addresses. But
Hmm.
Let's Encrypt is not doing that yet. But the way SATAs work, you can effectively glue the onion address in as part of an alt name to, so it's still in the certificate. So it's a
Hmm.
way to get a Let's Encrypt certificate uh, for uh, for a registered domain name, but also for an onion address, which is just another bonus.
Yeah, no, that's good to hear. Um, Going a little bit deeper into, I guess, the devices, the types of devices we're using right now. How do users then ensure they're actually operating on traffic secure systems, or can you actually verify that you're operating on a traffic secure system?
Well, as anybody who works in security, people who don't work in security, they'll say, "Is this secure?" And if and you somebody who works in security will say, um, "Secure for how long against which adversary to do
Yeah,
what sort of thing,
yeah,
in
a lot of
connecting to
nuance.
whom, and what So there, it's not a yes no question. Um, so there's a lot of subtlety there. Um, I would say that, for example, for Tor, the main way people to connect to the Tor network is via Tor browser,
Hmm.
and um, and the Tor browser bundle sort of incorporates the browser and also the Tor client that connects to the network, and of course this is signed by the developers of the software, but several years ago, they took a step further. So let me back up actually. So fundamental to the onion routing design is assurance and openness. So right from the beginning, I already mentioned that you need to have traffic being carried for multiple different kinds of people. If the only traffic going over it was Navy traffic, then if that was what you were trying to hide, you wouldn't have anything.
Right.
But so you need to carry traffic for diversely trusting individuals, not just people who trust the Navy and the U.S. government. Um, but that means that they're not going to trust a Navy-only network. So you need to have them uh, be allowed to run parts of the network. But you also just can't just hand them a blob and say, here's this code, trust us, it's fine, it's
Right.
perfectly good. So it has to be open source, and they have to be able to examine it. And you should, try to make it well spec'd and encourage people to pound on it so that they know. And that has been part of the security guarantees that Onion routing offers from the beginning. And our first publication release for code was 1996, because that was fundamental to it. But Tor has gone further than that. Um, and now coming back to the question you actually asked, uh, they have what they call deterministic builds. So people probably don't know this, but when you take software that's written by a person in a high-level programming language, when that gets compiled or interpreted by a computer, it's each time, even if you compile the exact same program on the exact same computer 10 minutes apart, uh, it will look randomly completely different.
Yeah.
So even if you know the source code's okay, who knows about this binary you got? Well, Tor, as of 5 or 6 years ago, they did a lot of work and they have deterministic builds. So you can verify that the same exact source code was used to make this build, so that the stuff that's signed, probably not the individual user, but you can be assured that experts have looked and seen, independent experts have looked to see that it's the same code that as anything else. So that's one way you can tell deterministic builds.
Good stuff. I'll take that, and we'll keep moving forward here. Um, in your opinion, or maybe in your experience, what are some of the things I guess pretty much anybody using the web, the internet, should be aware of when it comes to online privacy and security?
Well, I guess um, it's hard to be aware of everything, and and it's a moving target. So of course, you should be aware that there are cookies and all kinds of other things that can be used to track you, and
Hmm.
that even if you're connecting to a destination that that you want to identify you and authenticate, because it's your bank or your employer or something, there's still lots of things that can go on between the two of you. So one, be aware of things like that, and make sure your software is all up to date. And there's various plugins and extensions that can help you both keep track of and manage the extent to which different sorts of tracking things uh, are there, and you can try to control whether this cookies or JavaScript or other things that might uh, um, uh, be something you want to manage. So
Yeah.
um,
I don't know how recent maybe this trend started, but it certainly seems to be worse lately. Going to a website, The Telegraph, for example, especially journalism media sites, and getting this massive pop up about all these cookies we wanna run on your or we want to input on your device, and like the default, of course, if you just like close it or accept or what have you, is like the most privacy invasive. Do you actually take the time? Are you the type of person who actually takes the time to like open it up, open the panel, be like, no, 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 save? Because I am, and
um,
it's incredibly annoying, especially for Web3, decentralized company teams, organizations building decentralized technology. I find it incredibly hypocritical that they're asking me to put all these cookies on my device, whether it's my mobile device or my laptop, when we're supposed to be building more or less more privacy preserving tech where you don't need to know who I am. You don't need to give me a cookie. I can connect a wallet and authenticate that way, and yet you're asking me for like performance cookies and marketing cookies. I saw you start to nod there, so it looks like you are the type of person to actually open up the panel and go, no, no, no.
so yeah, I'm maybe a little neurotic in that respect, and I am inclined to do that. But you said, oh, it seems to be worse nowadays. I don't think it's actually uh, changed necessarily all that much super recently. Part of that is because there's legislation that says they have to tell you now. They didn't used to
Mm-hmm.
have to tell you, and now they
Right.
do, and they have to allow those options. So there's rules in various places. Um, uh, it's a tricky thing, because sites, in order to function well, they do need to know about performance, and it can be useful to understand where somebody was coming from and to try to provide appropriate services to them. So I think it's easy to just say, oh, uh, just don't do any of that. But I don't think it's inherently nefarious. I think it's convenience, but this happens all the time with any technology. You start to do something and it seems useful, and then you have to think about the implications as you move along. And I like it if that's designed in from the get-go, rather than, as I say, you bolted to the outside after the fact. But
Yeah.
um, yeah, I am inclined myself to mostly limit myself to the strictly necessary cookies, but I recognize that comes with a trade-off, and I recognize that for most people, they have no idea whether, what's going to work and what's going to break if they click something else.
We're coming up to time here, and I want to be certainly respectful of it. You probably need to do a little bit more prep for that ACM presentation. Unfortunately, I let my ACM membership that I had in 2010, maybe 2011 lapse. I didn't think I needed it anymore. But then, of course, as soon as I found out about this organization, I had a membership for a while. I got to read all these really cool research papers. I took I took it for granted that I just had this access there, and then after I left, I started seeing, oh, this thing presented in the ACM, some sort of ACM publication. And then, of course, events like this one that you're going to present at. I'm like, oh, I really wish I had, wish I had more time to actually pay attention to it. But unfortunately, when you work in the industry I'm in, you just end up head down, really focus on what Orchid's doing, and what some other teams that you appreciate are up to, and you start to lose sight of all the basic research that actually leads to a lot of the innovations that we end
I
up
remember
using.
back in the mid 90s, Mike Ryder, somebody else who worked in secure computing, uh, uh, he came together with a list of the ridiculous proliferation of computer security venues for publication. At the time, it was and it's so much smaller an hour than it is now. And I mean, in a way, this is a good thing that it has, people are aware and people are working on this, and the number of people working on security and privacy. The world is aware of that in a way that they weren't back then, and it was
Hmm.
in a way it was much easier to keep track of everything that was happening. That's just not possible even for people inside anymore. But
Yeah.
I bet that's a good problem to have.
I guess that as long as it all leads to something resembling a solar punk future, I guess it's all good things. Looking forward, or be reflecting on all the experience you've had doing a lot of this research, uh, uh, implementing yourself or seeing it implemented at least. What do you think some of the biggest challenges are surrounding digital security and privacy, maybe that you've seen this year, and especially maybe going forward?
Boy, I just
We
I
asked the big
don't.
questions here.
Yeah, and I don't. I couldn't pretend to answer. I guess partly, uh, if if I were a younger man, I probably just spout off with an answer. But one of the things I've learned is, no, you're always wrong. Like whatever you think is the big thing that people need to pay attention to. Uh, uh, Boy, I don't know. I mean, I've told you the things I'm working on. I'm still worried about, website authentication and internet destination authentication in general. It's not just websites. If you are logging into your company VPN and then you're doing all kinds of secure thing with your company, but it's not the company VPN because,
Hmm.
there
Hmm.
was a certificate hijack,
Domain
and
got
in fact you've
hijacked. Yeah,
just
certificate gets
leaked a
hijacked.
bunch of stuff that's shouldn't be leaked. That's important. I continue to worry and work on that. But what specifically are like the big things that's to some extent probably just reflects my interests rather than that's the big thing that is out there in the world. You know, uh, Data security and machine learning and how to do that in a privacy protecting way. Um, I remember several years ago, Vitaly Shmatakov started, pointing out, when people talked about personally identifiable information, he said it's all personally identifiable information when you start, intersecting all the databases together. Um, so, I mean, these all remain concerns, and but I think, as we just alluded to, there's lots of people working hard to, uh, as these things develop, to try to also make sure that they're protecting people. Particularly, I like to focus on how well are you protecting both people, but enterprises, their autonomy, their ability to manage the data that is about themselves and to
Hmm.
manage their own digital lives. Um, I like to take a long view. Several years ago, Charlie Strauss was talking at Usenix Security, and I remember he was saying in another 100 years or so, computer security is going to be as fundamental on Maslow's hierarchy of needs as, say, water, because identity theft won't mean what we mean today. It's going to be, hacking into the brainstem, and uh, so. What's going to be the problem next year? I don't know.
Fair enough. That makes me start thinking of shows like Altered Carbon and The Matrix, where you are literally like moving your brain, or in Altered Carbon, moving your brain to a new sleeve, or The Matrix, literally, something
Right.
jacking in, and that
Yeah.
both excites me and frightens the heck out of me, because
One
as
one of my
cool as it would be to to learn kung fu or learn how to unicycle really quickly, on the other hand, the potential negative side effects are not lost on me, and especially the ability for somebody to inject some malware into a package, and yeah, kung fu, but we can also control you from 3,000 kilometers away and have you do very bad
and you
things
thought
on
it
our,
was
on our
kung
behalf.
fu, but it's not. Yeah, one of my favorite quotes from literature is also relatedly from Charlie Strauss and from his book Accelerando. There was a group of people that are, I won't give you the whole story; it's complex, but they're in an environment and they're gradually being hacked by somebody. And there's an artificial life form that is the pet of one of the people, and uh, he manages to save them all. And they say,
Mm.
what kept you from being absorbed? And he says, you can blame your mother again for that. She's the one who was always updating the DRM software on my personality. He said, illegal consciousness is copyright theft sucks until some alien tries to rewire your hindbrain with a debugger. Then it's a lifesaver. Oh my gosh. So,
It's a bit of a long walk, but that was worth it. That's good. I'll raise one quick thing here, just to see if you have a perspective on it, and if you don't, that's totally fine. Uh, I
okay.
guess I guess the current potential doomsday scenario is that somebody figures out how to use quantum computing to just decrypt everything, right? You want to have man in the middle attacks whenever you want. Nobody knows. You're decrypting and re-encrypting on the fly. But I have to imagine that there's also people working on quantum cryptography that is resistant to that, just the same way that RSA or AES 256 and our AES 2048, if you can afford it computationally, offers incredibly strong protection against existing CPUs and probably even some ASICs.
Yeah, I mean, short answer is this is outside my expertise,
Sure.
but I am aware that yes, there's lots of people working on post quantum crypto, and in fact, Tor's handshakes have for a while been designed for post quantum, uh, uh, come the massive advance in quantum computing, over what they now have, that the security should remain, at least as far as the crypto handshakes go, and the crypto exchanges. Um, and yes, I mean, people are also working on ways to use that to produce more secure computation.
Perfect. Exactly what I was hoping to hear, and I think we'll end it there. Paul, thank you so much for taking time out of your afternoon to be here with us today. We really appreciate it, and good luck next Monday.
Oh, thank you, and thanks for having me.
My pleasure.